Hey everybody, hope you're doing well. Welcome to my office. It's kind of a mess, so I apologize. Maybe I can blur that out in post-production, I don't know. But hey, it is the way it is. I want to start a new series tonight, and I call it This Week in Regenerative News. So every week I want to bring, two or three articles that I find interesting to you guys, and to help hopefully elucidate some and strengthen some concepts that we talk about and discuss on a more regular basis. So I searched the interwebs, and I found three articles this week that I wanted to touch on briefly. The first one, and I'm going to post links to these, down in the description so you can read them for yourselves. But I just want to share my takeaways. So the first one I found in Pharma Times magazine, published this month, February 2022, and they're looking at a peptide approach to regenerative medicine. So what they want to do is take advantage of what we've learned about stem cells and how we can activate them and how we can get them to do what we need them to do. And what they're trying to accomplish is to stimulate endogenous stem cells with stimulatory peptides and or proteins. So they're trying to find ways to, as we've learned with stem cells, it's not so much the cell differentiating into new tissue that it's causing its effects. It's more the messages it's sending out. Keep in mind, the stem cell is a project manager on a construction site. Not really, he's not the guy carrying drywall up 3 flights of stairs, but he's telling people what to do. And that's kind of what the stem cell does. So if we can stimulate those stem cells to wake up and start sending out these regulatory messages, that could lead to, some sort of healing and therapeutic event. But having spent some time in trying to formulate myself viruses in graduate school and proteins, a key issue is stability. And can we deliver enough of the product in a stable conformation to exert the necessary, clinical effect? And therein lies some of the challenge that I think needs to be addressed. And that's kind of the other side of regenerative medicine is, building drug delivery systems to accomplish that. So, that's kind of an interesting approach, interesting concept. The second paper I found is from, I can't remember the name of this organization, but it's a paper where this group is creating synthetic stem cells. So what they're doing is creating PLGA microspheres and trying to encapsulate very stimulatory proteins within those microspheres that mesenchymal stem cells would normally emit to exert, whether it's immunomodulatory effects or other impacts that can sustain healing, repair, and regeneration. So that's kind of an interesting thought. There's been a lot of study. I mean, it's basically just delivering proteins in microspheres. But as someone who's worked a lot with microspheres in their past, it's very difficult because you're using a lot of solvents to form those microspheres with proteins in aqueous solution. And again, just like the last article, how do you stabilize those? How do you stabilize those to get effective bioavailability of a protein and the proper conformation to exert the desired clinical effect? So again, the second paper really focused on drug delivery more so than anything else. And finally, there's been since COVID came about, there's been a lot of interest in using regenerative technologies to fight COVID. And one paper, which is at news-medical.net, explores the relationship between stem cells and COVID-19. And they look at when you inject stem cells, they do localize to the lung. That's where they're filtered. If you do an IV bolus of mesenchymal stem cells, they tend to locate into the lungs. But again, what this paper, and correctly the author acknowledges, is that it's not the stem cells themselves that are differentiating to form new pulmonary epithelium. That's not happening. But it is the messages that these stem cells are sending out, waking up endogenous stem cells to start managing, local inflammation and getting that balance of pro-inflammatory and anti-inflammatory factors back in check. So that was a good little paper that just kind of supports that notion, because there are a lot of folks out there that thinks when you get stem cells injected into your knee that they turn into a new carpet of cartilage, and that's not what's going to happen. And I think there are a lot of articles out there that are misleading, and they infer that that is in fact what's happening, but it's really the trophic messages, the paracrine signaling that those exogenous mesenchymal stem cells are exerting that are really making the difference. So thanks for listening. We'll see you next week with some new articles, and stay regenerative, my friends.